Okay, so welcome to the Unit 4 lab on molecules and bonds, and this is the sort of introductory video. So as you know, in this unit, we're learning about bonds and molecules and their types of properties. And in this lab, you're going to explore how you can use that information to determine some unknowns. But before we do that, let's just do a quick sort of demonstration to get our minds thinking correctly about what we mean by types of substances, bonds, molecules, and their properties. So you notice I have three substances here. And your job first is to determine which one is sugar, which one's salt, and which one's mineral oil. So what you do is to take a moment to make your prediction just by looking at these three substances that are labeled 1, 2, and 3. All right, so probably just from looking at it, you were probably able to pick the mineral oil out, right? This last one here, number 3, it's a liquid, and oils are liquid, so you probably were like, oh, that's got to be mineral oil. You may not know what that is, but if you use baby oil is mostly mineral oil, and then some fragrances, so that's mineral oil. But what about 1 and 2? It's hard to determine just from looking at it which one's salt and which one is sugar. All right, so how can we determine that without actually tasting it? What we can do is we can test their properties. So in order to figure out which tests that we're going to do and also what we should be looking for, we need to first identify what these substances are. So what I have here is a list of the chemical formulas for sugar, salt, and this one is for mineral oil. All right, taking a look at their chemical formulas, what I want you to do is to determine what type of substance is it. Is it an ionic compound, a covalent molecule, or a metal? Pause the video now, and we'll come back in just a moment. All right, so looking at sugar, it's made up of carbon, hydrogen, and oxygen. These are all nonmetals, so that means that this is a covalent molecule. Sodium chloride, table salt, is made up of sodium, which is a metal, and chlorine, which is a nonmetal. So when a substance has a metal and a nonmetal, that's ionic. The last one, mineral oil, is made up of just carbon and hydrogen, and these hashtags are just representing some numbers because the number of carbon and hydrogens can vary in mineral oil, but these are both just nonmetals, so that of course will make a covalent molecule. Once we've identified what type of substance it is, then what we need to do in order to help us whittle it down and identify these unknowns is to figure out what properties we expect them to have based on the type of substance it is. So I've just listed several properties that we've been studying so far. Phases, malleability, solubility, which means whether or not it dissolves in water, and conductivity. Okay, so beginning with the phases. For covalent molecules like sugar and mineral oil, they can be of any phase. Now we know that sugar is a solid, so I'm just going to go ahead and circle that. And we know that mineral oil is a liquid. So in terms of predicting the phases for a covalent molecule, it can be anything, so you really can't make much of a prediction there. Ionic compounds, on the other hand, are always solid. So we know salt will definitely be a solid. The next thing we're going to look at is the malleability. So remember, malleable means that you can, if you bend it, it's going to bend, or if you hit it, it's going to dent. In the case of covalent molecules and also ionic compounds, if they're solid, they're going to be brittle. So that means that there's nothing that you can distinguish there in terms of properties of a covalent molecule and an ionic compound. They are both going to be brittle. Now, mineral oil, this doesn't apply because it's not a solid, so I'll just cross that out. Next thing is the solubility. So soluble, of course, again means whether or not something dissolves in water. And when it comes down to covalent molecules, some of them are soluble and some of them are not. If it's polar, it will be soluble, and if it's nonpolar, it will be insoluble. So because we don't have the knowledge yet to determine something is polar or nonpolar, what I'll do is I'll just tell you whether or not sugar is polar and whether or not mineral oil is polar. So sugar is polar, so I'm just going to put a P at the top for polar, and mineral oil is nonpolar. So based on that, which one do you think will dissolve in water? Great, so sugar will dissolve and mineral oil will not. Now, ionic compounds, most of them, or many of them, are soluble. So we would expect salt to be soluble, dissolve in water. Now, the last test that I have here, or property I have here, is the conductivity, whether it conducts or not. For ionic compounds, most of them are insulators, and the only time they will conduct is if it's an acid. So in order to test if something is an acid, we can use what's called pH paper, which is these little strips of paper here, and they change color based on the pH. If it's an acid, it'll be like a red or pink color. This yellow paper will turn red or pink, and if it's a base, it will turn blue, and if it's neutral, it will stay this sort of yellow color, okay? So it all depends on if it's an acid or not. So we would have to conduct that test. In terms of salts, for salts, they're all conductors. Okay, so let's take a look at these properties and sort of test it out. In this test tube here, I have a little bit of substance 1, so unknown substance 1. Again, we don't know what that is. And in this test tube, I have substance 2. So the first test I'm going to do is I'm going to test their solubility by just adding a little bit of water to it. So let's start with substance 1, and we'll see if it dissolves. So I just add a little bit of water to that, and I'm just going to shake it around. All right, and as you can see, most of it has dissolved. You don't see much of the substance anymore. So that would be soluble. So substance 1 is soluble. Let's go back to our chart here, and we're going to write down that it's soluble. Let's try that also for substance 2. Okay, and so again, you can see that there's no solid chunks left in there. It all sort of dissolved. So this one is also soluble. So far between substance 1 and 2, there's no difference. And I just want to quickly test the mineral oil. So here's our mineral oil. It's a colorless liquid. So to see whether or not it's soluble, what I have here is I have water. It's green. I dyed it green just so we can see the difference. So I'm just going to add some water to this and see if it mixes together. And you can clearly see this does not mix. So substance 3 is insoluble. And that matches what we've already determined about substance 3 because it's nonpolar, so it shouldn't dissolve in water. All right, so the solubility tests are done. Now the last test that I'm going to do here is conductivity, because so far there is no difference between substance 1 and 2. They look the same, they're both soluble in water, so how could we determine which one is soluble and which one's salt and which one's sugar? All right, so what I'm going to do is I'm going to add some water to both the containers. So this one is number 1 and this one's number 2. And I also have a container of just plain water here on the side. This is just water. Now for the conductivity, I'm going to use this conductivity meter. And the reason why I have the water there is because I need to test the conductivity of my water. Now if we were doing this in the lab, I would use deionized water and the test would come up as being an insulator, meaning that when I add the conductivity meter to it, it doesn't light up. Unfortunately, we don't have that luxury. I don't have deionized water at home, so I'm just using plain old tap water. And tap water actually does have a little bit of minerals dissolved in it. So this will probably light up, but we'll see how much it lights up to determine if it's a conductor or not. Oh, first I got to turn it on. All right, so as you can see here, with my regular tap water, only the red one lights up. So we're going to consider that if just the red one lights up, it's an insulator, okay? So for our test, when the red one lights up, it's just an insulator. Now, the next thing I'm going to do is, before I test the conductivity, I want to just quickly test the pH, because remember, if something is an acid, so if sugar was an acid, it would actually light up, and then in which case we couldn't tell the difference from the conductivity. So I have a pH strip here. I'm just going to get a different one. And as you can see, when something is neutral, like water is neutral, if I dip it in, it doesn't change color. It sort of stays this yellowish color, okay? But if it's an acid, it'll turn color. So let me try the other side with substance 1. So substance 1 stayed the same color. And I'll try for substance 2. It stays the same color as well. So that means that these are all neutral, they're not acids. So this conductivity test will work, because this should only light up, it should only conduct for the salt and not the sugar. So let me go ahead and dip this into number 1. And as you can see, only the red one lights up. And again, for our test, that means it's an insulator. Okay, so take my probe out, I'm going to clean this off. And I'll write down this is an insulator. And also it's neutral, right? It wasn't an acid. Okay, I'm going to do the same thing now for substance 2. Whoa, wow, look at that. It is lit. So we've got both the red and green, so that means that this is a conductor. All right, so this is a conductor. And it's also neutral as well. So this means that substance 2 must be our salt. And I know that because it conducts when dissolved in water. Now remember, salts don't conduct when they're solid, so if I were to try this on solid salt, it wouldn't work, but when it's dissolved in water, it works. All right, that's it for the demo. So now what you're going to do is you're going to collect data for your lab doing the same test. And all you're going to do is watch a series of small, short videos that show you how to, that show you the data results. You're going to add that to your table and then use that to identify some unknowns.